Hello, I'm Ibrahim Rufai. We'll be talking about convolutional neural network. In introduction, convolutional neural network are somewhat similar to the restricted Boltzmann machine, RBM, and O2 encoder. But instead of learning single global weight matrix between two layers, they aim to find a set of locally connected neurons. CNN are mostly used in image recognition. Their name comes from the word convolution, which simply means filter. In short, filters are an easy way to perform complex operation by means of simple change of convolutional kernel. So the three basic concepts behind convolutional neural networks are convolutional layer, the pooling layer, and finally the output layer. So we'll be discussing these concepts with the diagram as follows. So basically in this diagram, what it explains is, suppose we have a 7 by 7 image size matrix, which we can see from the source pixel. We define a weight matrix which extracts certain features from the image, and we have initialized our weight matrix here as the convolutional kernel to be a 3 by 3 matrix. This weight shall now run across the image such that all the pixels are covered at least once to give a convolved output. The value of the convolved output here is -8. It's obtained by adding values obtained by element-wise multiplication of the weight matrix and the highlighted 3 by 3 part of the input image. Think of the weight matrix like a paintbrush painting a wall. The brush first paints the wall horizontally and then comes down to paint the next row horizontally. Pixel values are used again when the weight matrix moves across the image. This basically enables parameter sharing in a convolutional neural network. The weight matrix here behaves like a filter in an image extracting particular information from the original image matrix. A weight combination might be extracting edges while another one might be extracting the color and another one just blur the unwanted noise. The weights are length such that the loss function is minimized, similar to an MLP. Therefore, weights are learned to extract features from the original image, which helps the network in correct prediction. When we have multiple convolutional layers, the initial layer extracts more generic features, whereas the network gets deeper, and the features extracted by the weight matrix are more and more complex and more suitable to the problem at hand. Finally, I would like us to discuss the convolutional neural networks from the input layer down to the output layer. So the image here we're seeing here gives us a simple overview of how the architecture of a convolutional neural network looks like. And first of all, we pass an input image to the first convolutional layer. The convolved output is obtained as an activation map. The filters applied in the convolutional layer extract relevant feature from the input image to pass further. Each filter shall give a different feature to aid the correct class prediction. In case we need to retain the size of the image, we use seam padding, also known as zero padding. Otherwise, valid padding is used since it helps to reduce the number of features. The pooling layers are then added to further reduce the number of parameters. Several convolution and pooling layers are added before the prediction is made. The convolutional layer helps in extracting features as we go deeper in the network. More specific features are extracted as compared to the shallow network, where the features extracted are more generic. Finally, the output layer in the convolutional neural network, as mentioned previously, is fully connected layer where the input from the other layer is flattened and sent so as to transform the output into number of classes as desired by the network. The output is then generated through the output layer and is compared to the output layer for error generation. A loss function is defined in fully connected output layer to compute the mean square loss, which is also the gradient of the error. The error is then propagated to the update filters and values, and one training cycle is completed in a single forward and backward pass. So this is basically what happens between the input and output layer of a convolutional neural network. And I am Ibrahim Rufai. Once again, thank you for listening.